obviously YouTube.
This call is now being recorded.
Thank you. Okay, so oh ya, ini sekejap ni apa? Ni KMP, mana skema dia? Ni. Agak gumpuan. Okay. So Bismillahirrahmanirrahim. Okay, so today we will be continuing on for chapter 8, which is limits. Okay, today we'll only be focusing on chapter 8, and I'll be using KMP, last year's paper, as my medium for teaching this topic. Okay. So even though this is an objective question, but it's better you write down the steps, because as far as I know, for PSPM1, you guys have to your format will be in subjective. So working is very important. All right. So for the first question, okay, we have a one-sided limit. Okay, so if there is like this negative symbol, meaning that it's approaching from the left. Okay, so first things first, we see here there is a modulus function, or absolute function or modulus. And what we must do is first we have to make it as a piecewise function. All right, so just by doing this, x minus 2 is equal to x minus 2, where x minus 2 larger equal to 0, and negative x minus 2, x minus 2 is less than 0. Okay, so from here, we have to first simplify the restricted domain there to get x bigger than equal to what, and then less than equal to what. Okay, so
Irfan.
yeah.
Tapi kami ada buku buku like macam set soalan.
Buku set soalan macam?
Dia macam set soalan PSPM lah.
Oh, dia by bab ke atau macam mana?
Dia campur. Dia kira set.
Oh, korang dah dapat dah buku
So, madam just suruh buat yang tu je lah.
Oh, yang KMK sediakan lah? Yang diorang buat
Yang baru ada, yang pasif ada.
Nanti Arina share dalam group
Okay.
Alright. Assalamualaikum Zaifah. Sorry. Sebab kita baru mula je. Okay. So it's okay, no problem. Tak ada masalah. Kita baru nak go into our first question. It's okay. Sebab memang tadi kita tunggu, dan saya pun dah mula record dah. Okay, no problem. But okay, let me recap first. So today we'll be learning chapter 8. And then for this question, okay, first for this question, we know that this is a one-sided limit. Means that we have this like negative symbol here. It is trying to tell us that it is approaching from the left. Okay, it is approaching from the left. So, and then we have this absolute function. So first we have to make it as a piecewise function, then we could determine which function we will be using based on the limit lah. So this is the limit that approaches to from the left. So okay, before that we have to simplify this piecewise function. Okay, so now we have to simplify the domain. So now we have x minus 2, where x is bigger than or equal to 2. Negative x minus 2, x minus 2, where x is less than 2. All right, so now, since the limit here, it tells us that it wants the value when x is approaching 2 from the left, then we will be using this function here. Okay, we will not be using x minus 2, because that is for approaching from the right. Okay, x minus 2. Okay, but if you want to visualize it, okay, let me write a linear graph here. Okay. So this is a piecewise function, and this is here, and this is 2. So over here, this is approaching from the right, and here is left, approaching from the left. So this is the domain. Here, this is for the domain where it's x less than 2, and here is the domain where it's x then bigger than or equal to 2. So right now, the limit wants us to find where x is approaching from the left. Therefore, we will be evaluating here, this side. So we will be approaching from the left. Therefore, we will be using negative x minus 2, because it satisfies the limit that we want to find out. Okay. So from here, okay, that's not space. Hold on, let me rearrange this. I'm gonna put up here. Okay, so right now we will be using first write down the limit, and then we used x squared minus 4 over, wait, we can factorize x squared minus 4 by using this formula, a squared minus b squared, this theorem, which is a minus b, a plus b. Okay, so from here, we can factorize this, so it will become x minus 2, x plus 2, divided by negative x minus 2. Okay, so make sure you guys know how to create a piecewise function for a absolute function. Okay, and then you guys know how to determine which one that you will be using, whether it's x minus 2 or negative x minus 2, based on the limit itself. Like this, for this question, the limit is approaching from the left. Therefore, we will be using negative x minus 2 based on the restricted domain, okay, which is x is less than 2. Okay, so from here, we could simplify this function. You will get negative x plus 2, meaning that we will get negative 2 plus 2, which is negative 4. So the answer should be B, okay? But remember, working is very important. So it's crucial to show that you create a piecewise function for the absolute function, and then is important as well to determine which one that you will be using for your limit here. If you have to evaluate limit, I am confused. Okay, so for that symbol, right, is apart from the definition of the absolute function, it's always bigger than equal to and less than. Okay, as far as I know now, if I look back in my other books, let's say I have this book here. Let me just find it real quick. Where is the book? Dah, ada buku satu lagi ni. Baik. Ni buku lain. Ni belakang tu. All right, based on this book I have here, which it says here that memang saya ikut definition dia. So definition memang bigger equal to less than. So if you look at it, okay, I'll send the definition on WhatsApp. So hold on, let me find this. Now here is the definition. So the book I used for this definition was the Pure Mathematics A level, right? But here is similar as matrix, the definition of the absolute function. So the domain will always be bigger than equal to and less than, okay? That is, it will not change. It will always, we will use that definition. All right? Okay, Ulaifa. Any questions so far? Yes. Memang fix. No worry. All right, anytime. Okay, so let's move on to the next question. So here we have, okay, obviously, right, if you direct substitute this function here, you will get 1 over 0, 1 over 0, negative 2 plus 1 over 2. In here, you will get 1 over 0 and 0. So obviously, you can't evaluate this because 1 over 0, you can't like compute it directly. Or we have HI all on it. Hello HI, it's okay no worries, walaupun lambat apa, kita baru je soalan kedua. Okay HI, no worries, kita baru soalan yang kedua. So nanti file ni saya my solution here. Saya share lah dalam WhatsApp group, okay? But it's okay. So far kita tadi we were discussing on how to evaluate limits if there is a modulus function and a one-sided limit, meaning that for this question here, we were discussing on where two approaches from the left, and then we are dealing with an absolute function. Okay, so you didn't miss much. Just you have to look back into the solution that I've made here. Okay. All right. So so for the next question, right? So if we direct substitute this value, we'll get 1 over 0. Obviously, we can't compute this value. So what are we going to do? That's the question. What are we going to do? Right. Let me think. So okay. Okay, let's expand first. All right, let's see what happens. No, we do not expand. The trick is in this bracket here, you should combine it to become a singular function. A singular function, I'm sorry, a single fraction, meaning that you multiply, you make sure the denominator is the same. So what I mean is limit as x approaches 0, 1 over x, it will be 2 plus x minus 2 over 2x minus 2. So from here, you can simplify the numerator here. Then you go down, you write down this similar thing. Now you are left with x over 2 bracket x minus 2. So from here, right, from here, you could expand it and you can simplify the numerator and the denominator here. So you could simplify it very easily because they have a common factor. So, and then you can direct substitute into this new function we have here that we have already simplified. Okay. So from here, you will get, wait, 0, sorry, what did I write? 2. Okay, so you direct substitute this value into this function, and then you will get 1 over 2, 0 minus 2. Therefore, it should be negative 1 over 4. So that is your answer for this limit. So how do we determine which one that we will be using? So for me, right, if you are, wait, let me put this in bracket. If you are used to solving limits, then you could see the solutions or the methods that you'll be using. But if you want to try and like expand this, wait, if you want to expand 1 over x, I never tried before, but let me think. I mean, if you expand it, right? Okay, let's say if you initially you expand 1 over x, right? Let me write another solution here. Assume that you expand it like this: x squared minus 2x plus 1 over 2x. Can you get the same answer like I did, but a different method? So let's combine these two first, because we know that if we direct substitute, then we will get the previous solution where it's 1 over 0, which is we can't evaluate that. So let's try and make this as a single fraction. Okay, so we have 2x, x squared minus 2x. Okay, so from here we could obviously simplify, and then we can factorize our denominator here. Here we can factorize to get x squared over 2x squared, x minus 2. And then as usual, we will get the same thing lah. We will get the same thing. All right? So either you caught on early that you have to you make it as a single fraction inside of this bracket, or you could expand 1 over x and then you simplify, you factorize until you get in this form here. Okay, both methods are acceptable to me. Yeah. All right. So any questions so far? Anyone that wants to clear up any confusion for this question? Yes, it's troublesome because one, obviously you can simplify, but you have to factorize again, meaning that you expand and you factorize again. So it takes more time. But for my first solution here, you don't need to factorize. You just have to simplify, and that is it. Nonetheless. Okay, Arina, you have any questions so far? HI?
Tak ada, tak ada.
Tak ada, eh? Okay. Sorry tak kalau saya bising sikit sebab tengah makan.
Tak apa, tak apa.
Okay. So the answer should be dia. It should be. So let me check the screen. Oh, yep, it is correct. All right. The value of k. Okay. Yeah. Okay, so this question is really, well, it's nice. Okay. So if they give us this limit, the value of k is, okay, so how do we find k? And that's the question, which is really interesting. Okay. Limit as x approaches 1. Okay, we write down this here. Okay, let's simplify this. All right, let's simplify. So this, okay, let me write down equal to 10. So limit as x approaches 1, k, we factorize k because it is the common factor, and then we will get x squared minus 1 over x minus 1. This should be equal to 10. All right, now, can we factorize x squared minus 1? Obviously, we can, because 1 is also equals to 1 square. So then we could follow the original formula, which is this one. And then limit as x approaches 1, k, x minus 1, x plus 1 over x minus 1 is equal to 10. So can we solve it? Yes, we can, no problem. So assuming that this question, right, it says that k is a constant. Okay, we know that k is constant. So remember your laws, limit laws, where you could bring out your constant outside from the limit. So you could write down as this: k limit x approaches 1, x plus 1 is equal to 10. Then you could just direct substitute. You get 2k is equal to 10. Therefore, k is 5. So that is your answer lah, Dadu. Okay. So what are the important things that you have to know for this question? First, you have to know your limit laws, your factorization, simplify the expression, the function. But if you guys like direct substitute, right, I forgot to mention this. Obviously, you will get the intermediate form where it is 0 divided by 0. So refer back to the notes that I sent in the group, which is this one, if you recall back, this one. So this is a cool map, like a method on how to plan ahead on evaluating your limits. Okay, so you could refer back to the map that I shared in the group. Okay, so from here, since it is an intermediate form, okay, I have to find a way. Either I factorize it or using conjugate. So from here, I factorize it, and I solve the limit. I know that my k is a constant value, meaning that I will bring it outside from the limit. Then I could evaluate limit as x approaches 1 for x plus 1, and then solve for k using algebra. And then finally, I will get D as my answer. All right. So any questions? Can we move on to our next question?
Yes.
Yes, huh? Uzaifa, HI? All right.
Yes.
All right. So let's move on. Okay, so this is chapter 9, but which I will not solve that. So let me find another limit. This is chapter 2. This is chapter 1. This is chapter 5. Nope. Functions. I think this is limits. Is it limits? Yeah, asymptotes, right? Yeah, it's limits. Okay, so obviously they will not ask you this question like true or false. But for fun, let's try solve it. If you really want to test your understanding for limits, then you should try out for this question. Wait, it asks for a domain, is it? Oh no, it asks for domain. Okay lah. Since it asked for the main, which is chapter 5, yeah, this one. Question 12. Yeah. I have to. How about Friday morning? Okay, no problem. Okay, let me charge my phone. Okay. Okay. So evaluate this limit as x approaches to infinity. Okay. As x approaches to infinity. So, okay, I have a plan, but I don't know whether or not it works. But I'm gonna try. Where? Square x. Yeah. So, okay. First, right. As limit x approaches to infinity, I multiply its conjugate, meaning that I do this. I multiply by 1. So means that square of x plus 2 minus square of x. I want to try because it's been a while for this type of question, but let me have a go out of it. So you will multiply it, but it's conjugate like this. Okay, then you guys expand. So expand this. And then you will get x plus 2 minus x over square root of x plus 2 minus square root of x. Simplify. Okay. Yeah. Let me get my calculator. Hopefully I'm not wrong. This is my nervous laughter, but yeah, let me get my calculator. Supposed to be right. We will get our answer for our limit here. So square root of x plus 2. Okay, assume that since this is approaching infinity, right, our value of x will be larger. So let's try and substitute larger values. Let's say if I substitute 1000. Okay. All right. If I substitute 100,000, what we would get? Yeah, let me substitute more numbers. Okay. All right. So if you guys don't remember about this method I'm using, okay, you could use the calculator. But how do you use calculator? Okay, do you guys want to see me using the calculator? Is it? I could show you for a brief moment. Yeah. Okay. Assuming you guys want to, so let me just open my camera here. Okay. Hey. Yeah. Yeah. Okay. Okay. All right. So if you want to compute using our calculator, right, it's very easy. If you want to check, okay, if you want to check, then it's easier. So write down the function into our calculator, x plus 2 minus x, this. All right. So if you, for example, right, if you take the value of x, 1000, like this, okay. Wait, yeah, let me write again. So that, yeah, square of x plus 2. Okay, first write down this function. Okay, write it down, and then press this calc button here. You could evaluate any kind of value of x, or any kind. So what happens now? Okay, so we know that x is approaching to infinity, right? So the values will be, for x values will be larger than ever lah. Whether you substitute 100, 1000, and 10,000. So let's see for 100, what happens there. Okay, obviously our value will be like 0.099, but it doesn't tell us much. But let's see what happens if we evaluate for 1000. Okay, just press calc here, calc, right? And then just enter 1000 and then press equal sign. You will get 0.0316. So before this, it is 0.099, and then it becomes 0.0316, right? Okay, let's evaluate more. So let's go for 10,000. Oops, my camera. Yeah. Let's evaluate for 10,000. So just press cut as usual and then just evaluate 10,000. And then for this, you will get, okay, 9.999, meaning that 0.00999. So if you guys compute bigger and bigger values, right, it will be 0.00009. So eventually, right, as we're approaching to a bigger number, then what happens? It will become it will become closer to zero. So that is one way to check your answer. But how do we do it? Okay, how do we show that it is zero? So one way is if you direct substitute, then you say, if you state lah, as x approaches to infinity, that it will approach to zero. Or you could use this one, you multiply by its conjugate, then you will get limit as x approaches infinity 2 over, sorry, this should be plus, not minus, on my denominator there. So square root of x plus 2 plus square root of x. Okay, we know, obviously, just now, there's a minus sign, right? So basically, we can't determine whether it is negative or positive, but obviously, what I showed just now is closer to zero. But over here, we know this value here will always be larger lah, positive, meaning that you will add up numbers as goes on. Like if you substitute 1,000, then you will get some larger value. Then you substitute 10,000 and you will get some larger value and so on. So I would like to recall for denominator, what happens if we increase the value for the denominator? Say A is our constant, and let's say X is our denominator. And if our value for our denominator becomes larger, then our value for this function here will be smaller and smaller and smaller, and to the point where it is going closer, approaching zero. Yes? So that is my idea. So when you evaluate this limit here, you know that the denominator will never be negative. Like it's a non-negative number, what kind of number you substitute towards infinity. 1,000, 10,000, 100,000, it always becomes a positive number and it becomes larger as well. And this is for our denominator lah. Our numerator is a constant, so you don't need to worry about it. But right now, our denominator is becoming larger as it's approaching infinity. So we know that as it becomes larger, meaning that this limit will becomes closer and closer to zero. 0.001, 0.00001, to the point where it will be zero. Therefore, you don't need to substitute x with infinity, okay? Because infinity is not a value. It's just a concept where you're trying to say that x is approaching to infinity. It's not a number. So you can't just do this. You can't just substitute infinity plus 2 plus infinity and no. I know if you just do this, then you will get 2 over infinity, obviously. Then you'll get 0. But this is not the way to show lah. All you have to do is just show it lah. Just write down 0. Okay, just write down 0. I don't think that you have to like substitute infinity because infinity is not a number, all right? Just a small reminder, it's not a number. So let me check the answer. It should be 0 lah, B. And this is question 12. Yes, it is 0. But yeah, the question here, right? Oh, yeah, it use conjugate as well, but it divides square root of x. I see. But the final answer, right? This scheme writes down as like x here. You substitute it as infinity, which is wrong. Mathematically, it is wrong because we can't substitute something that is not a number. Infinity is not a number, so we can't just do that. But yeah, just evaluate like this lah for me. Okay, for me. Or if you want to be fancier, you could, yeah, let me think. We know that for our denominator here, wait, why is it negative infinity? We know from here, our denominator, our smallest power is square of x. Okay. Remember, if you want to evaluate infinity, then we should like divide the smallest power on its denominator, right? For example, limit as x approaches infinity for x divided by x squared plus x. So how do we solve it? Obviously, you can factorize it. Sorry, my bad. Okay, let's say 1 over x squared plus x. So you have to determine the largest square. I think the largest power or the smallest. Yeah, the largest power. So from here we know that x squared is the largest power. Therefore, we divided by all the terms. All the terms we divided by x squared, meaning that limit as x approaches infinity for 1 over x squared divided by x squared plus x divided by x squared. We know for a fact that 1 over x or any kind of variable, if we know x is infinity, then it will be 0. Or as x approaches infinity, that it will eventually become 0. So therefore, this should be 0 over 1 plus 1 over 1 plus 0. Therefore, it will be 0 lah, obviously. But if you don't need, honestly, right, for this question, you don't need to write that down. We know that for our denominator here, will always be approaching in positive infinity no matter what. And then eventually it becomes 0. Okay, you don't need to do anything, I think. So that is why the answer is B lah. Okay. This is a really tough question to explain if you can't imagine it properly, but yeah. But if you want to visualize it, then I could show you on my Desmos here. Desmos is a really important tool if you want to like see how the graph is. Okay, so let me just graph it out for you guys. X plus 2. Oh, sorry. And then minus square root. Oh, sorry. Okay. Square root of x. All right. So as you can see, right, from this graph, the graph is going closer and closer to the x-axis, meaning that is eventually will become 0 lah, as it goes closer to the x-axis. So this is how you like try to recheck your answer. Okay, but algebraically, like this, I mean, this is the way to do it lah. This is the way to do it if you want to show it. But yeah, let me think. What happens if I 2 over 1, yeah, 1 over 1 plus 2 over x, obviously 0, and then plus 1. 2. Wait. 2, 0, 1. Wait, where is it? Why did I put negative one? Wait. Okay, let's ignore it for now. So basically, right, this is how you do it. I think you don't need to show anything besides this lah. But if you guys are having doubts still, can you guys like help me ask your lecturers for my working here whether or not it's correct? If it's correct, then you should tell in the group lah. Okay? Boleh, siapa boleh wakil? Tanya je, betul tak apa yang saya buat ni? My working. Arina ke, Echai ke? Boleh? Tapi so far kalau dengan saya ni, okay tak? Faham tak apa yang saya terangkan tadi?
Faham.
Faham Echai okay, Echai? Faham Okay. Asalkan semua faham, saya okay. Sebab itu lah, sebab saya terangkan tadi, harapnya faham Okay, sekejap saya makan dah. 8, 9. Oh. Jadi kalau korang nak makan ke makan lah. Memang betul-betul 8. Okay. Alhamdulillah. So, for this question, it wants us to find the constant. Okay. 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 So jadi nak bas tak nak sekejap. Kusut tangan. Okay. So determine the value of the constant C if f of x is equal to for this piecewise function. Iya continuous. Okay, memang Melayu dengan English yang kita gabung. Okay. Alright, so for this function, right? First you have to, okay, what is the first, obviously it says continuous, nonetheless, obviously, that's a good thing. They mentioned that it is continuous. So if it's continuous, right, then obviously limit as x approaches a value for a function is equivalent to f of c, right, if it's continuous. So from here, can we evaluate? Yes, we can. Since it is continuous, then we can evaluate this limit here. All right, so for this function, if you want to solve this limit, then we have to use conjugate. We have to multiply by 1 or a conjugate lah. So what is the conjugate of square root of x minus 2? Is square root of x minus 2 times with square root of x plus 2 divided by x minus 4. Oops, it looks like a lambda, sorry, x minus 4 square root of x plus 2. Okay. So remember, the numerator here, it looks like a square minus b square, which is equal to a minus b, a minus c. Why minus c? It should be a plus b, sorry. Okay, so so we will get limit as x approaches 4. X minus 4 over x minus 4 square root of x plus 2 is equal to 1 over c. Yes. So we could simplify this function. We are left with wait, this is really I should write up here so that you guys can see what I'm trying to do. Okay, after this question, I'll be showing you another method if you have another idea. Okay, so we are left with limit as x approaches 4, 1 over square root of x plus 2 is equal to 1 over c. So just direct substitute, you will get 1 over square root of 2 plus 2, or 1 over c. You will get, oops, not 2, sorry, 4. And then we will get c is equal to what? Equal to 4. That is our answer. No problem. So continuity, what are the criteria for it to be continuous? First is f of c must exist. Limit x approaches c for a function must exist. Therefore, limit x approaches c for a function is equal to f of c. Therefore, that is continuous. Okay. All right. It has to fulfill all of the criteria which I mentioned just now. It has to. If not, then it is not continuous. Right? Hopefully you guys remember. So as I mentioned, another method. Okay, so another method is we write down x approaches 4 square root of x minus 2. X minus 4 is equal to 1 over c. So can we factorize this? Honestly, right? We can. But how? But how? Okay. So if we go back, right? If we go back to our formula here, a square minus b square, a minus b, a plus b. Right, so x here, we could like express it in another form, which is, okay, let me write this down. Okay, so x square, square root minus 4. Okay, because 4 here is 2 squared. So from here, right? From here, you could factorize the denominator and you will get limit as x approaches 4. Square root of x minus 2 over square root of x minus 2, square root of x plus 2, which is equal to 1 over c. You could factorize this function, no problem, no problem. You will get limit as x approaches 4, 1 over square root of x plus 2, 1 over c, and you should get the same answer, which is 4. Okay, you should get the same answer lah. Oops, no, my answer scheme, what is the answer? But I'm really confident that it is 4 lah. Right, so there are two ways to do. Whether you multiply its conjugate or you factorize the denominator and simplify the function, then you direct substitute. Okay, there are two ways, no problem. Same thing. Okay, so any questions so far? If there is no questions, then I can move on to another set, I think, because that's the only questions for limits on this paper set here. Okay. No questions, huh? Hopefully you guys have, well, I'm not hoping, but hopefully you guys understood what I explained just now, okay? This is for physics, wait, I need to, KMK Kulim, wait, ni KML kan, Labuan, HI Labuan, including Huzaifa, is it? Both of you are from Labuan, right? So let me find the paper for KML. Kelantan, Selangor, Pahang. Ada tak? Kalau tak ada, question, solution. Tak ada lah. But it's okay lah. Alright. KMS, KMG, sekejap. KMG, tak ada. Sorry guys, tak jumpa lah yang Labuan punya. It's okay. But I found a set, alright. It's okay. I found the set. This is what I want. Yes. Ni saya nak. Okay, soalan ni. So saya akan share dalam group. But don't worry, right? If you are getting used to solving these questions, then you have no problem lah. Inshallah. No problem. So let me send it into our group as usual. Okay, this is another set. All right. So let me just quick share this. Okay, you guys can check out the questions in the WhatsApp group, which I already shared. And let my saving file. Okay, where is it? Here it is. Okay. So, yeah, I just know we can factor. Yes, we can. We can factorize x minus 4. Honestly, right, as long as the 4 is a perfect square, then you could factorize it, no problem. Right? You could use it. Okay, I'm gonna take a 2-minute break. All right, wait, no, 1-minute break. I want to drink some water a bit, and then we could move on for this other question.
Ifan,
Yo,
nak tengok jalan kira yang tadi?
apa? Nah. Mana? Alright. Okay, Aina. Dah okay dah soalan ni? Oh. Right, so kita teruskan dengan soalan ni. Okay, so finally I found, well, honestly, right, I didn't realize they have this subjective format. So, okay, no worries. Kita boleh. So as usual, this is a, well, not a straightforward question, but still a question. And let me just do this. Wait, let me wait. Saya fikir jap. Okay, alright. So saya tengah fikir lagi. Alright, so this is a scheme. Alright, if you guys want to try on your own, there is a scheme answer for it, then go ahead. Good luck. All the best. Alright, so let's try to evaluate these limits, right? So first we have a limit where, well, it is a rational function where its denominator is a quadratic function. So let me lock it. Okay, so first, can we factorize it? The denominator, obviously. So, sorry. Limit as x approaches 4, x minus 4 over, okay, let me rearrange the terms. So it will be negative x squared plus 3x plus 4. One of the mistakes, right? One of the mistakes that student frequently makes is this negative. Why do your lecturers, right, always remind you on factorizing the negative coefficient for x squared? Because we know that you guys use calculators, right, to evaluate, obviously. So we know the calculator will only factorize. Okay, let me give you a demonstration. Right, try using your calculator by factorizing this quadratic function. Sorry. Just put -1, 3, and 4. You will get x minus 4, x plus 1. If you expand this factor, right, you factored your quadratic function, you will get x squared minus 3x minus 4. The question is it equivalent? No, right? So that is why you have to be cautious. You don't just go straight off and just put into your calculator. You have to determine and to see, is your coefficient for x squared, is it a positive value or a negative value? If it's a negative value, I recommend you guys should factorize the negative value first, then you factorize the whole quadratic function, right? So from here, you get limit as x approaches 4, x minus 4 divided by negative x squared minus 3x minus 4. Then you can factorize this, x minus 4. So it will be what, x minus 4 and x plus 1. Right, x minus 4, x plus 1. Then you could simplify this function, no problem. The limit as x approaches 4, 1 over negative x plus 1. Then it should be negative 1 over 5. So that is the answer for the limit. For question E. Okay. Any questions so far?
No.
Tak ada.
Tak ada, eh? Okay. Hopefully you guys are aware before you evaluate those limits. Okay.
Sebab
Hmm.
kan kalau nak faktorkan negatif tu kan, kalau tak tulis, tak apa tak.
Maksudnya macam terus buat macam ni eh?
Kita tu main dalam tu.
Tapi ni adalah. Sebab kat calculator dia tak tunjuk tau ada negatif tu. Nanti kadang takut nanti Arina buat macam ni. So dia tak sama. Nanti jawapan dia 1/5. Okay, alright. Alright. So that's how we evaluate the first question. Now the second question is conjugate as usual, because as we know, if we just direct substitute into our function here, then we will get the intermediate form, obviously. So this will be -5. So obviously there are two ways. One is you factorize x minus 25, or you multiply by its conjugate lah. But for me, I like to try new things. So let us factorize x minus 25. So limit as x approaches 25, this will get square root of x plus 5, square root of x minus 5, divided by square root of x minus 5. So from here, you could simplify, then you could direct substitute into your new function. Then you will get 10. That is your new value, 10. Right? But if you want to direct multiply by its conjugate, then it's the same thing, honestly. All right, let's do it. I'm gonna show you. So limit as x approaches 25, x minus 25 over square root of x minus 5 multiplied by square root of x plus 5, x plus 5. Then you will get limit as x approaches 25, x minus 25 square root of x plus 5 divided by x minus 25. So boom, boom, boom. As usual, you get the same value. All right. These two methods are, you can use any method lah. As long as you know, as long as you avoid the careless mistakes, then you should be fine now. Okay. So any questions? Can we move on to question C?
Yang atas tu macam mana dia boleh jadi se-X?
Okay, itu kita tengok balik yang tadi. Mana yang ni? Mana? This one. So I use this formula here. Yeah, I use that one. So try and see what I did. Okay, how I factorize it. Okay, I know.
Okay.
Mana soalannya? Okay. So let's go to question C. Now they give us a limit when x is approaching infinity. So so is square root of 3x power 4 plus x over x squared minus 6. Okay. So honestly, right, if you want to divide all the terms with the higher power for the denominator, which is x squared, like x squared divided by x squared, then minus 6 over x squared, so on, then you may. But for me, right, I use this method, which I factorize. Okay, first I determine the highest power on my denominator here, which is x squared. So I should get limit as x approaches infinity, where if I factorize our numerator, right, which is x to the power 4, okay, but later I'll show you why I factorize x to the power 4. So it will be 3 plus 1 over x squared. Yeah, x squared, x cubed, divided by x squared, 1 minus 6 over x squared. And then for x to the power of 4 and square root, what happens? Okay, it will become this modulus function, a absolute function, and square root of 3 plus 1 over x cubed divided by x squared 1 minus 6 over x squared. For this, right, if you found an absolute function for a quadratic or a even power, for example, x to the power 4, x to the power of like this, right? X to the power 4 or x to the power 6, so on. You can ignore the absolute function. So means that, okay, for x approaching infinity or even negative infinity, right? Before this, if we are dealing with like absolute x or modulus x, then you have to consider whether you use x or negative x, because this is for when x is approaching infinity, and this is for x is approaching to negative infinity, where we create the piecewise function and then we distinguish between those two. But why do I say it doesn't matter? Because x squared will always be positive, no matter what kind of value, right? Whether it's a negative value or a positive value. Negative 2, it should be 4. Negative for 2 also will be 4. So x squared, it already like makes the y value positive. So it doesn't matter if you put an absolute function or not. It will always give the same output. Okay. Therefore, you don't need to write the absolute function, but I write down. Okay, the reason why I write down is because I don't want to like forget about modulus x if I get used to it. All right. So I just write it down as usual, and then right from here I could say x squared, because we know that x squared will always be positive no matter what. And if you put a modulus function, it will still keeps us giving the positive value. So 3 plus 1 over x squared is x cubed divided by x squared. 1 minus 6 over x squared. Okay, so we could simplify, no problem. And then from here, we know that obviously a rational function, right? For this, 1 over x cubed, always positive, becomes bigger as usual. When it becomes larger, then as larger becomes, it will always be closer to 0, including the denominator, 6 over x squared, where x becomes larger and larger, it becomes closer to 0, meaning that it will become 0. So square root of 3 plus 0 over 1 minus 0. Therefore, this should be square root of 3. Okay, so hopefully that will be the answer. Let me see. Yes, obviously. Yes. So tada. So these 3 questions, right, really test your knowledge on how to evaluate limits. If it gives us an intermediate form, then you have to use the notes that I gave you. Okay. So I think that's about it for today. Honestly, right, I want to extend, but it's already late and I have a meeting tonight. So any questions so far?
Tak ada.
Tak ada, eh? How about Ichai and Huzaifa? Okay.
Okay.
Okay. Huzaifa, okay. Lee. Okay, all right. So, inshallah, let me check my Google Calendar. I want to see when I am free. So, okay. All right. On Wednesday. All right. How about Wednesday? We will do a 2-hour session. Wait. Okay. Wait. Let's not go too far. Okay. I was thinking, right? We do a 1-hour session and then we take a break for like half an hour and then we continue on. How's that sound? Do you guys agree?
Boleh.
Yeah. Okay, so since that's the case, okay, so I'll be doing it like, okay, how about from 9 until from 9 to 10, then we take a break for half an hour, then 10:30 until like 11 something. Okay, not too long. If it's too long, then you guys will be sleepy. Obviously, you have class on Thursday. Okay, so how's that sound? From 9 to 10 and then 10:30 to 11.
Boleh.
Boleh.
Boleh? Okay, nanti dalam group nanti saya akan as usual lah, saya akan message for our next session. Okay, so before class, I would like you guys to try another set. Okay, memang kita fokus untuk limit saja. Okay, first you guys kalau ada masa, kalau you guys ada masa, boleh try for this question. Okay, you guys can screenshot it first, or you guys check your file lah, and then save it. So this will be the question that we will be discussing next class. Let me save the file first before I forget. I usually forget. Wait, pure. No, this is metrics. Yeah, this one. Alright, so next class we will be discussing this, and then for our next paper or set, let's try and where is my Telegram? Honestly, here it is. Okay, just now we did set 1. Let's do set 2. All right, it will be interesting. We see set 2 also limits as usual, nothing new. Yep, limits. Yep, this is one. All right. Okay. All right, try to answer only limit questions, okay? But if you guys are ambitious, if you guys really are hardworking students, you could try chapter 9 and you could ask me lah whether it's right or wrong. Okay. If you want to ask in the group, then it's fine as well, so that everyone could see what kind of question you ask and then which one is right or wrong. Okay. So let me share it in a group for the file. So the new file which I sent is the file that we will be discussing after we discuss this set for this Wednesday. Yeah, for this Wednesday. So let me before we end the session, I would like to end the recording because I forgot to stop the recording.